Hello everyone, Peter Newman from WeedSmart with you. Thanks for joining us this morning. I'm joined by the one and only Dr Roberto Busi. How are you, Roberto?
I'm good, all good here, trying to have a go with this screen sharing, but yeah, it's all good.
He's a bit tired. He's been up all night preparing his slides for the presentation this morning. No, he hasn't really. It's all very organised, and we're going to hear some good information about testing your herbicides for herbicide resistance. And Roberto, I think it's the biggest screening in Australian history. Anyway, Roberto, 21 herbicides, is it, by 600 plus samples? That's got to be some sort of a record. So we're going to, obviously can't share every last detail of that data, but we're going to, I think, cover knockdowns, then pre-ems, then post-ems, and have a look at all of that. So a little bit more about WeedSmart before we get started. We always like to acknowledge our stakeholders and our key contributors, all of those businesses above the line there, financial supporters of WeedSmart. We're very grateful for their support. And so the GRDC, the chemical companies, Bayer, Syngenta, and the Gold Partners. Below that, a lot of other chemical companies, seed companies, and also you'll notice there the mill companies, Seed Terminator, Redicop and HSD join the WeedSmarty tribe and contributing and supporting. So really great to have that really varied group of people supporting WeedSmart and helping us bring things like this to you. So we have also our very valued in-kind partners below that line there. We value their support also. So that's enough about WeedSmart. Just last comment this morning, please, questions. So we'll use the questions or comments box. We'll keep an eye on that as we go. And as Roberto's presenting, I'll interject with questions as we go. So please get the questions in as we go. So I'll hand over to you, Roberto, let you take over. Hopefully you can share your screen and start sharing these amazing slides that you've prepared for us today.
Yeah.
Here it comes.
The screen has just been shared. Swap.
It's good.
And then just a bit of a pointer.
Oh, that's next level.
Look at that.
Laser pointer.
Look at that.
Very
yes, well, good morning or afternoon or night, depending on where you are from, to the hundreds of listeners that we have today with us, or the ones that will watch this, the recording of this webinar. It is about testing quite a large number of herbicides and understand the current level of herbicide resistance in annual ryegrass. As seeds were collected late 2019, early 2020, so very fresh data with some of the data just collected 2 days ago. It wasn't only me, it's a big team. It has been a big team, 3 assistants, Paula, Martina, and the 2 master students, Bowen and Jada from Brazil, and then the one it's me that have done all the bits and pieces and the overtime work over many weekends and organized the funding and basically have this set up for 2020. I have to acknowledge before we start that this has been made possible because of the UWA has shared and provided the infrastructure, and the BASF provided initial seed funding, without which we wouldn't have had this exercise or research going. And it was about before the launch of Laximax, Cinmethylin in Australia. We wanted to understand how the herbicide would have performed against ryegrass and whether there would have been resistance, and we will touch on that later on. As you mentioned, Pete, sample size, almost 600 samples in the end tested, and that was the size of the samples received. At the very least, we had we asked to growers and agronomists to collect 100 heads of ryegrass and then send them when they were dry. And we prepared the seed. We put the seed in pots, in trays. So for the pre-emergent herbicides, we had about 200 seeds that received direct application of the herbicide over the top. And then the post-emergent herbicides were applied to a number variable between 10 and 50 seedlings. Foliar application at 2 leaf stage plants. And then we scored resistance after about a month when there was maximal injury observed. And so we categorize resistance when we see greater than 20% survival in each respective sample. When we have between 6 and 19, we call it developing resistance. Otherwise, we have a score as a susceptible sample. And that is in response to full herbicide dose, or the dose that I chose has the maximum allowed on the herbicide label. And so which were those herbicides? It's a big table, difficult to read. Essentially, we had 5 foliar herbicides focusing on Clethodim, ACCAs, and imidazolinone, and then Paraquat and Glyphosate for the foliar. And then we had 16 pre-emergent herbicides with several standalone against binary mixtures. And you can see the mixtures are many of them, about 30% of the herbicide treatments. So we will go through the key results, starting with the, following a chronological order of when those herbicides are applied during the growing season. So generally we have, if the weather allows and there is enough moisture and therefore enough with germination of ryegrass, we have knockdowns applied prior to sowing. And so we tested Paraquat, the commercial name is Gramoxone, maximum rate allowed, 1 liter per hectare. I added 1% of methylated seed oil, Aysten in particular, because from my previous pot research, even though it's not, suggested that you use such a high percent of oil, I've seen that I could consistently better kill and more rapidly susceptible control. So the susceptible control has been put across all the treatments, and we then call for resistance when the susceptible control was 100% killed, and we then observed some level of survival in the sample submitted. So there is not much to say, really. It worked really well. I mean, those plants have been sprayed in warm conditions, which is end of February, early March in Australia. And the herbicide worked really rapidly, and I did not see any resistance whatsoever. The efficacy was full
Not one. You didn't even find one plant to keep and test for the future.
Well, there is definitely some variation. I repeated the experiment when the temperatures cooled down in winter. And this is what I am up against. On the left-hand side, you have the response of a highly paraquat-resistant ryegrass collected from a vineyard in South Africa. And on the right-hand side, you have many plants sprayed with 1 liter in winter conditions. And you can see this haircut type of effect where the paraquat action is fast, and but probably doesn't translocate to kill fully the plants, and so the plants grows back. And the ability to grow back is different from different populations. So there is a bit more than everything susceptible. There is a bit of variation, but at the moment I haven't seen anything that is comparable to our resistant control. So again, variation in response to paraquat has been seen 30 years ago in the population in particular. If you want to name names, is VLR69 had 1.5-fold of let's call it decreased sensitivity to paraquat. And so far, it has never evolved to a level comparable to our resistant control. So, it's something that definitely is worth keep an eye on. But in the large screen, I haven't seen anything that was outstanding. So Peter, interrupt me whenever. Otherwise, I touch on glyphosate, and then we can pause a little if there is any comment coming through. So similarly, I screened for resistance to glyphosate. I use PowerMax, so 540 grams per liter. I use 2 liters again, consistent with 1% of ASIN oil. Similar story. You know, glyphosate probably doesn't benefit of being mixed with a lipophilic oil, but I've seen that I wanted just to make sure that everything was perfectly applied and uniform sort of application. So this is the results I had. I had very high efficacy again, and 1% of the population, so 6 samples across the 600, were, in my opinion, highly resistant, and 4%, this number are expressed in percent, and so 4% of the pool of sample screen had what we call developing. So where, you know, there were definitely a few plants that could survive the herbicide. And so, yeah, this is low level. It was a surprising that piece of data, a piece of information, especially because in other labs, you know, the number is maybe tenfold greater. And so what I did, I retested most of the samples in winter. And again, I had some, also more importantly, some of the agronomists that submitted the samples were a bit disappointed because they believed they had some level of glyphosate resistance in their farms. They didn't communicate me prior to that, and that is actually something that it's probably a good thing to share as many information as anybody has. You know, if you suspect for something, it's good to tell me or to tell when, you know, to anybody that does this type of screening, because it, first of all, raises the level of attention, and also it's good to eventually be able to connect what happens in the field and what we see in pods. So the systems are different. We try to close the gap as much as possible, but you know, even from an epidemiological point of view, it's always good to know whether what we see in trying to detect for resistance relates to the epidemiological events, like how many shots of glyphosate those samples have received. Anyway, without derailing too much, I retested in winter, and I confirmed the 1% that were highly resistant. In this case, I identified 4 main types of responses. So the first one, resistance, is where basically plants almost seem unaffected. They keep growing, they are healthy, and there is a great proportion of them. There is what then I call developing, where, yeah, there is a lower proportion of those plants, but they are able to regrow. And so they are affected more than the resistant ones, but they can regrow, and you can see lots of green material in those 9% developing. So altogether, this says that in Australia there is 10, in my opinion, when you spray 2 liters of PowerMax, 10% of the samples are resistant. All the other 2 categories, nearly dead or fully susceptible, where everything is absolutely killed unequivocally. Yeah, those 2, I don't think we should call them resistant. You know, the nearly dead have a high level of damage. Yes, sometimes there is some green tissue, but this is almost like a stay green type of symptom. I don't think that is resistance. And yeah, those data have been just collected, and I will then have to communicate back to who submitted those samples and see what the feedback is.
So Roberto, I remember quite a few years ago, I think the Department of Agriculture in Western Australia did quite a big survey in Southwest WA, and from memory, I think about half of the ryegrass had some glyphosate resistance. I'm not sure if I've got that right, but I think it might have been done at a lower rate. Just wondering if you can shed any light on that.
Look, you get what you do, and the response of this is not an absolute response. This is a response to a specific dose of glyphosate and a response to a particular methodological approach. Here, these numbers are plants that have been sprayed with 2 liters. I recorded their response. With the method that we have established here over the years is then to cut those plants back, allow them another few days to recover and spray them again. And when you do that, the response is very clear. You know, the 10% of the glyphosate of the populations that I call resistant, that is univoc. You can't get it wrong. While all the others, where you have some green that stay green, or a lot of damage, or highly suppressed plants that take forever to die, you know, those plants are killed. So again, there is a big variation. There is a big variation in response to glyphosate, and probably we have never taken enough time to consider all of that. You know, there are many papers in the literature, even in species where glyphosate resistance has not occurred. For example, blackgrass in UK, there is a big variation in LD50s when they are calculated. Just a recent paper speculating that glyphosate resistance will evolve because of this variation seen in response to one treatment of glyphosate. So yeah, there is everything and in between. It's not just a black and white. In this case, my point was to minimize the false positive, and I am very confident of this data. Here they are broken down into different states. Of course, the New South Wales data are quite scary because of the small number of samples tested, while you know all the others are about at least 100 samples. And again, the WA data here is 6 + 1, 7. 7% is what Michelle Owen in random surveys found, you know, even in 2015. So that is the threshold. I'm very, you know, is not a made up data. I'm very happy to see this absolute 100% reflection of the two sort of data set done a few years apart, and probably because we share the same methodological approach, trying to minimize those responses that could look for resistance. But you know, the important thing is to apply the scientific method. So if you see something, and I'm not sure whether the deeper the type of data, anybody has gone in and understood and repeated those data and repeated those studies, you know, this needs always to be repeated. And guess what? Because I had two sort of different responses, I have a full set of seedlings waiting for me, and yeah, Sunday they will be sprayed once again. So I will have a third round of a third go, and you know, just to try to clarify, you know, and get as close as possibly we could to the actual real value of glyphosate resistance in
okay. I know you're Italian, Roberto, but that was a very long answer. Anyway, all good, mate. I think what's happened in New South Wales this year would agree with that. There's been a lot of glyphosate-resistant ryegrass found in New South Wales this year and other states. So I think that is probably, even though it's only 20 populations, it's probably a fairly fair representation from what I'm hearing.
Yeah, well, again, they came from farms where something was suspected, and in fact, you know, it was on those New South Wales samples that there was this sort of half disappointment on the fact that I couldn't see it. And in part, I blame the fact that in summer I only tested between, you know, 10, 20, 50 seedlings at the very best. And so these issues, especially, you know, we are trying to call for resistance by screening, you know, one dose applied once, maybe twice, and that's it. So it's not easy. It's a difficult exercise. This has to be repeated, and I'm glad that I repeated and I came up with this different number, and now I will communicate. And it's a never-ending process of getting rid of mistakes. And I think that the method that I'm using is just making sure that I don't have false positive. And the false negative, meaning killing or overkilling a resistant plant, in my opinion, is not such a big issue. I've been always, and I am always worried about misleading the industry in giving numbers out that are, a bit scary and maybe not reflecting what is actually happening.
Yeah, fair enough. That's good, mate. Well, we'll keep pushing on. No questions coming through yet, but just a hello from one of our internationals in the Philippines, I think. Great to have you on board in the international audience. Yeah, but I'll leave it to you, Roberto. Keep your questions coming in if you have any.
Yeah. So yeah, what's next? I think that there are exciting new products in the PPO inhibitors sort of mode of action. Here's something that we call spikes. So this is just one example. It's a product commercialized by New Farm in 2021, and similar behavior and similar efficacy you have from another product that will be commercialized by BASF, Boraxtor, and so they are quite surprisingly highly effective. This is the lowest of the potential registered rate of this herbicide applied onto 2 to 3 leaves ryegrass that is glyphosate and paraquat resistant. So it is the pot that I was showing you before, and this is a photo just taken a few days after. So they are extremely fast in their action, and and this is a standalone, and it looks very effective. Those plants have some ability to recover, but most likely those herbicides will be mixed with a knockdown. So again, to increase the efficacy, and yeah, they are quite promising, and most likely they will be introduced into the next round of testing for ryegrass. So let's go to the preamps, and we start with an easy case here. Propyzamide, I put in the orange box the commercial names of this herbicide. And yeah, basically I applied to the full rate 1 liter, and there was no emergence at all, 0. After many weeks, this is all I could see. And so, yeah, easy to record. I mean, it was so effective that it won't be included in the subsequent testing going forward in 2021. Trifluralin, I mean, I want to present all the preamps. I spray them many and in many mixes, but I think that the one that is mostly and widely used is Trifluralin. And so this is the data that I have across all the samples in Australia. Basically, I applied Trifluralin at 2 liters. Again, this rate was chosen incorporating lots of feedback that I received from the agronomists. They wanted specifically this rate tested. We know that even at lower rate, we can kill the susceptible ryegrass, but they wanted me to test for something that it is used in the field at a similar rate, and this rate was very robust. Of course, it killed fully susceptible, and this is what is just a snapshot to show you. These are trays that have been retested, samples being retested. All those samples are from Western Australia, so there is some resistance in Western Australia. You can see in those 2 left-hand side little cells that there is quite a high number of ryegrass that can survive the 2-liter application. But this is a photo that has been taken yesterday, and it is almost 3 months after the application of the herbicide, and basically it has been highly suppressive and has been lasting according to his chemical physical characteristics. Is very persistent, and no seedlings have emerged. You have maybe 1 here, so it would be I put 100 seeds in this case in each cell, and so it would be a 1% survival if that is a true survival.
What was the rate, Roberto?
2 liters. 2 liters
2
of Trifluralin 418.
And is that applied to the seed and then soil on top?
Apply to the soil on top in this potting mix, which has a high content of organic matter. And so very different situations that you would expect from South Australia. You know, this is just not cherry picking traits, but it's just to give you an example of how much more widespread is in South Australia. So if you look at the data, yeah, Australia at the top as an average. Of course, the average is very much affected by, you know, the numerosity of WA samples, but this is divided by states. In New South Wales, I took it out because it was 0, only 20 samples, 25 samples tested. So in South Australia, yeah, there is a high level of resistance to trifluralin, even when you apply such a high dose. A bit less in Victoria and significantly less in WA.
Roberto, can I just ask you about that right-hand column there, that percent control? Is that overall percent control across all of the trays?
Yes, yes. Mm-hmm. Yeah, it's very high. It is very high. You know, we are in optimal, perfect conditions when the herbicide is applied to the naked, clean seed. So something that in the field is impossible to achieve. High water rates, and so a lot of zeros that eventually basically zeros in terms of survival, a lot of hundreds. And so eventually that has a massive weight into the overall efficacy. But this is what it could be achievable. And of course, you know, and again, this is an efficacy that is assessed a month or six weeks after the herbicide is applied. As we know, in the field, trifluralin breaks down, and there is anecdotal evidence that it's breaking down faster and faster. So you never get this 90 plus percent of control. You know, you are happy if you can get 80% type of control. But again, here the point is, yeah, in the main point is to detect resistance. And so we want to see whether there is the virus is resistant or not at a massive rate. And this is what you get, you know, it's highly effective. Then the other issue would be to try to mimic what happens in the field. And yeah, that is a more difficult thing to do, and it's more difficult to give an accurate number of what could be the efficacy that you can achieve in the field, because, you know, the soil and all the environmental factors are at play, not to mention rainfall, to activate those pre-emergent herbicides. And yeah, because I tested so many mixtures, I just wanted to put in perspective what was the efficacy or the level of resistance seen to trifluralin standalone. You know, this is Australia-wide. When it is mixed with Arcade is the commercial name of prosulfocarb, so lipid inhibitors, or Avadex, which is trialate, similar mode of action, but different characteristics. Avadex work really well in summer, and we will see later on a bit more about that. When it is mixed with Sakura, which is pyroxosulfone, group K, very long chain fatty acid elongase inhibitor, or Laximax, which was the brand new herbicide, Cinmethylin, again, new mode of action, just commercialized in Australia. So yeah, there is no question. There is a very significant drop in level of resistance. Highly resistant here. So the percent of samples that were highly resistant to trifluralin standalone or the mixes, yeah, definitely are more effective, and also in the category of developing resistance, you know, there is a drop in the percent of the samples that were scored as having some low level of resistance. And the efficacy, you can see, the efficacy we go even higher than 99% in some cases. Any question?
No, you're doing well, mate. All good. Keep on going.
So yeah, this is a photo that I took a couple of years ago when I first realized how effective the mixtures with trifluralin were. You know, you have trifluralin standalone at the bottom, and even, you know, there would have been some emergence in some of those in response to some of those mixes, but you know, even this delay in emergence, considering that the crop is growing, is definitely putting a lot of crop competition into or against the ryegrass. And yeah, for some of these mixtures like trifluralin and trialate, in this case, were only Western Australian samples. I couldn't find any resistance. So let's have a look at the photos from this year. You know, it's just a comparison of a snapshot of how those 600 samples look in response to a mixture of, this is trifluralin plus prosulfocarb.
So Roberto, we really need to just point out, on these trays, what do we have, about 24 paddocks per tray, is that correct?
20 per tray.
20 per tray, and so that there is several hundred paddocks in one photo, is that correct?
Yeah, it's 583, the whole lot. It's the whole lot.
Excellent.
And again, you know, this is about 2 months after the herbicide had been applied. And so, of course, if you have some plants that are resistant, those plants keep growing. There is not much competition. And yeah, it may not look as good or may not be as informative. I just wanted to show you what was in comparison, all the mixes in comparison one to another. And if we go to the next one, you know, pretty much we have, and I flick back and forth a bit, so don't get dizzy, but it's just to show you, you know, the difference in efficacy that there is between swapping between Arcade and Sakura. There is yeah, less number of plants when this powerful mix is applied. And again, if you go in and count the number of plants, these plants are big. There are not many. Of course, there is a small percent of those samples that are resistant to it. As you would expect, you know, it's also expected that if you use a greater dosage of herbicides to mix together, you know, you get a much greater efficacy. This is the nature of many dose responses, you know, when we try to quantify resistance and we try to quantify how plants respond to herbicides, the greater the dosage, the greater the efficacy, so the lower the survival. So this is expected, but is yeah, I thought it was just interesting to share what I've seen at the end of the experiment, basically. And so this is with trialate, again, highly successful. Of course, when you see those patches, those samples, you know, came, most of them were from South Australia, because there is high level.
Trialate rate, Roberto?
3 liters.
3 liters plus 2 liters of trifluralin. Yeah.
So yeah, this is a 5 liter rate. Is again, maybe very expensive, maybe everything. This is just, again, purely focusing on, can we kill all of those plants?
Oh, that's good. That is the practice, although this is applied to naked seed, so very effective way of doing it. But yep, that's good.
And then yeah, with Cinmethylin. So again, highly effective. Yeah, surprising. You know how effective the trialate is, and yeah, Cinmethylin also was highly effective when it was mixed with trifluralin. And so let's have a look at what Cinmethylin did standalone, and when it was mixed with all these other herbicides. This was you know, the core of the experiment, basically. This is what we had been funded to do in comparison to everything else, and these are the results. And so in response to Cinmethylin was 500 mils, you know, the full labor rate. We found in summer, the susceptible was fully killed, and in some of the samples, there was survival, and that allowed us to categorize in summer conditions that 2% of the population were resistant and 20 developing. I put an asterisk because there is a bit of a follow-up on those ones. High level of efficacy, and high level of efficacy when it is mixed with all these other 4 herbicides: pyroxasulfone, prosulfocarb, trialate, and trifluralin. Of course, not of course, but the mix with Sakura is off-label. So I just want to point that out. And I thought that would have been the outstanding best treatment of all, which wasn't, because as you can see, the mixture with Avadex was the most effective of all of them. This is the most effective treatment that can be, selectively be used in wheat. And you can see the snapshot, this, you put in comparison with everything that we have seen so far. And yeah, there was virtually no plant surviving. There are a few plants there that I don't know how they made it through. And so this was very effective, very surprising, because I believe that, and I go back one, I believe, and I will show you the data to confirm that, the fact that we have seen those level of resistance and developing in response to Cinmethylin is because of the highly volatile nature of the herbicide, which basically the dose delivered was not as nearly effective as you would have in cooler conditions. And I will show you the data that I got in winter. Sorry about this. But when it was mixed with trialate, it was dynamite. Absolutely, yeah, almost virtually no surviving plants. And yeah, this is another snapshot, bird eye photo. Laximax on its own, so Cinmethylin on its own, trialate on its own, 3 liters, Laximax 500 mils, and the 2 together. Like it was, yeah, unexpectedly effective.
Roberto, these are pretty amazing photos, and this really gives me a lot of confidence in all of your data in the mix and rotate strategy, where we can have obviously some survivors to the individual herbicides and none to the mix. And you've got lots of examples of this that you'll show us in the coming years, I think. I don't suppose you can explain it exactly, but is it just a dose thing, or is it just the difference in the genes of resistance, or you just have to do more work to understand that?
Well, we always have to do more work, and it in my opinion, is very much dose dependent. If I have to be critical in the experimental setup, and I will try to mend that in the following year, is that all of these mixtures treatment should be compared to the 2x dose of each standalone instead of 1x. 1x, of course, is what you have in the field, and we don't want to start to suggest that we should use twice the level rate. But from a scientific point of view, you need to compare, what we would call equivalent toxicity. So to understand what type of interaction you need to compare with something that is as strong as comparing standalone versus a mix. It's good, but the standalone has to be twice the dose, and so that you have a more interpretable sort of comparison, I think.
Just a bit more work for you. Instead of 21 herbicides and mixes, you need to do 42.
50. Yeah. Just go to the 50. Oh, well, next year, this is what I'm planning to do. Maybe less mixes, but more of standalone 1x, 2x. And so then we will have a very good comparison, and I think will be very useful. Of course, then in the field, the economic kicks in, and we want to go actually half dose of both. Although, we have done 10 years of research on not cutting the rate, and when you hear that people will still now have seen the benefit of the mix and they want to go in and cut the rate of both, you wonder whether we have been talking to who. But, the economics drives everything. We want to maximize the profit and try to delay or manage the infestation of ryegrass. So we try to anticipate a bit of the market. We try to give the best confidence in the end. It's boosting the confidence of many agronomists and growers that are are facing a massive challenge, and they need tools, and they need to optimize the use of the technology.
Yeah. Okay, Roberto, we've been going for 40 minutes now, so we'd probably better get a bit of wriggle on and finish it off in.
Yeah, finish off with the fact that Laximax tested in winter gave me 100% control. So this was, again, very mind-blowing. We did the experiment in March, early March, and we had 20%, 22, putting them all together. We did that in April, and that was less. And we did in April on the highly resistant population, and already the level of resistance wasn't there anymore. And then I did it in winter, spraying 1st of June, and this is what I have. This herbicide has been very persistent, and there is no one seedling across all these 500 plus samples that has emerged. So very persistent and highly effective. And I wonder whether the volatility is at play. There are definitely some biotypes that are less susceptible to Cinmethylin, but again, more work to really clarify, maybe with C14 label that has been provided to us, C14 label Cinmethylin, try to understand the metabolism of ryegrass at different temperatures. But in winter, this is a very big resistance breaker. We have so much focus on the mixtures, but I would use Cinmethylin standalone, and I would use it. Yeah.
Bit of a loaded question, but I spoke to you earlier, and perhaps next year you're thinking about doing all of your testing in winter rather than trying to get your resistance test results out in time for the season. You might be sort of sampling one harvest, testing in winter, and then using those test results the following season. Is that sort of the way you're starting to think?
Well, there is a middle ground, which is the testing in April, May. And so then, there will be still the data available by June or, mid-May. Many of the the logistics is decided in Christmas. So, whether we do it in February, March, doesn't really matter. Most of the decisions are already made, and this data need to be valuable for, the next 5 years at least, or decade. So yeah, definitely I want to move a bit forward the time of testing to allow, ryegrass to be less dormant and have, a more realistic set of temperatures that gives less of these issues of volatility. But again, this is trying to extrapolate to the maximum. I can see that, the summer conditions were quite good. In some cases, allow me to pick up some issues that I would have never picked up. For example, the volatility issue maybe is an issue for this herbicide to be applied in dry seeding. That is the nature of how these herbicides are used, and so that was trying to capture a little bit of that. But yeah, this is an important result, and just to compare to what has happened with Sakura tested in similar conditions in winter. Of course, on the right hand side you have some population that have some level of resistance to Sakura, but yeah, I was very surprised in pots. So it's an artificial system, doesn't reflect necessarily what happens in the field, but I was very surprised about the persistence and the longevity of the Cinmethylin applied in pots in winter. It is very effective. And Sakura is the best herbicide we've got. So just to be clear, it's or at least it is the one that is most sold and has a very big slice of the market. So this is the one that everything has to be compared with. And let's move on quickly. Next year there will be another resistance breaker coming through, and we have done a bit of research on it, and we will be definitely incorporating into the testing. And finishing off with another example of how the mixtures are providing, additional efficacy. This is Clethodim, and when Clethodim is mixed with butroxadim, then the efficacy is greater. Here you have basically a comparison of the same sample spray with Clethodim and the mix, and sometimes even the mix can't kill the ryegrass like this one. There is definitely less plants surviving, but sometimes it is not fully effective. And this is the last slide I have, which is full of data, which probably is unreadable. But as a rule of thumb, I found that resistance to Clethodim versus resistance to Clethodim and butroxidine, it is basically twice as much. So Clethodim at that rate, which is the maximum allowed on the label, the response of ryegrass is, in terms of resistance, is twice as much. And yeah, I found this very interesting because it was also reflecting some of what has appeared on Twitter, that a particular agronomist was relying on the mixture of Clethodim and butroxidine, and he was really blessing this mixture. And yeah, it's interesting enough, maybe just by chance, that I have this highly effective, high efficacy observed in samples coming from Victoria. Look at that, you go from 11% resistance down to 1, or a third of the developing. So it's a significant result. I think it's worthwhile keep testing on that. Maybe the fair comparison would be 1 liter of Clethodim. That would be also a very interesting piece of data to have. And I conclude here with the contacts. I definitely have a Twitter account with a few followers, and yeah, if you think about anything that you want to share, or trying to plan for next season, there is an email that I just made yesterday, and Paula, one of the team, will reply to you and try to organize the next season of testing.
Thanks, Roberto. So just to be clear, the service is going ahead next year, and it will be probably a slightly different list of herbicides, but reasonably similar service. Is that right?
Yeah, it goes on. It will be a smaller sort of effort for many reasons, logistics, maybe 400 samples of ryegrass, and then 100 or 150 of radish. 19 plus 1 herbicides. We are in negotiation to have this plus 1, which is herbicide is coming in 2 years. So, very exciting. Very exciting stuff. And try again, as I said before, we try to anticipate the market a bit to see into what is coming, and have a feel of how effective those new solutions are, and what they can complement, how they can complement, and what is the value of this new herbicide options going forward.
Yeah, excellent. Now, we had one good comment from Paul Levis, going all the way back to talking about glyphosate resistance. He said in southern New South Wales, we had multiple knockdowns through summer and autumn. We normally are lucky to have one. And prior to sowing, and the pre-emergent herbicides do most of the work, but this year they saw multiple applications, and that really showed how much glyphosate tolerant or resistant rye is out there. So he said scary was his comment. So so certainly it showed up in New South Wales, and I think I've seen a fair bit on Twitter about that, suggesting that that's a pretty common observation, Paul. Thanks, Roberto. It's been great. A lot of data there, lots of photos of pots and lots of paddocks. So appreciate your time. I think we might have one more question come up. Just once again saying great to listen to and enjoy the enthusiasm. And thank you, Paul. So just a few final words about WeedSmart. Once again, our partners, we value very much. Thank you very much for their ongoing support. And also we have another webinar coming up in a couple of weeks' time, I believe, handling weeds in high residue farming systems, the strip and disc farming system being one of those high residue farming systems. So Dr. Michael Walsh and Greg Condon will be presenting that. Super looking forward to that one. I've been watching strip and disc closely, and we had a strip and disc field day the other day, and I fielded the question 5 times about whether you could capture weed seeds with a stripper front. And the answer is yes, but you have to tune in to find out a bit more about that. So Roberto, thanks for that. Any closing comments from you before we finish up?
No, well, it was a pleasure, to share what has been many weekends of work. Summarizing in a few slides.
Yeah, good on you, mate. Thank you very much, and thanks for putting in the weekends. We'll look to present this data in other ways as well, so that everyone in WeedSmart can get a look at it. So Thanks everyone for joining us. So that next webinar on Friday, the 25th of September, once again at 11 o'clock WA time. Thanks, Roberto. Thanks for joining us, and we'll see you next time.
Cool.